All right, welcome back. So next I want to talk about the analysis tool pack, which you'll need. Oh, by the way, here I am. I found a camera so that you can see me. So you can see me rooting you on as you watch this. The analysis tool pack is something that you're going to want to download into your Excel file to make sure that you are able to use some statistical tools available through it. So most of you probably already have access to it. And what you need to do is go to File, Options, Add-ins, and then you will see the tool pack. And then you would hit Go. It will ask you to pick, and then you'll hit OK. And then it will automatically show up under your data screen. So data, and then data analysis. And that gives you a choice of the kinds of things that you can later use in our statistical semester, so to speak. So that is something that you want to do sooner than later. Now to go back to descriptive versus inferential statistics. Again, one of the biggies that I want you to know for the purpose of our class, because it's so core to what statistics actually involves. So again, the descriptive statistics focus on collecting, summarizing, and presenting a set of data. And so, for example, the Table 1 in Dawson-Long, which shows means and standard deviations, is actually descriptive, okay? And so let me show you. I'll pull up that article. And let me see, here we go. Okay. Okay, so here's Table 1, and you can see that what's shown here, the mean and the standard deviation, both of which per Chapter 3 on descriptive statistics are descriptive. So for those of you who said inferential, which was a number of people in the class, you would be incorrect. They are descriptive, so it's describing the data. So that's one example. And the Jean Bartunek article also had, which pretty much everybody got right, descriptive statistics. If you remember, basically it gave a percentage of AMJ reviewers who basically had stated, some particular attribute is important. As you can see, my dogs are in the background making noise, or as you can hear. Let me put this on pause and go take care of them. Okay, so back and hoping they're a little bit better. The inferential statistics is based on making conclusions about that larger population based on the particular sample. So as one example, I wrote, based on data from 200 coaches, say how satisfied they are in their careers, we make larger conclusions about all coaches. So I would say pretty much all journals have descriptive statistical information, and frankly, most have some sort of inferential statistics, usually in the form of hypothesis testing, in which, say, 200 career coaches are surveyed, and then we make larger generalizations to all coaches, and that's how we use statistics. Now, to be sure, let's take a little bit of a step back. Quantitative research designs rely on statistics, as do mixed method studies. Some use solely descriptive statistics, but most have at least some inferential statistics. One key is that research involves drawing a conclusion about a population of people based on some characteristic. So the characteristic might be coaches and their backgrounds, that is, whether they're psychologists or non-psychologists, the practices that they engage in, behavioral modification, goal setting, etc., and their ability to create positive changes in the clients, behavioral change, learning, etc. But getting data from the whole population's way too costly and unrealistic, so researchers rely on a sample. And the goal is to be able to draw conclusions beyond the sample to the larger population. My hope is, this is really key to even thinking about. Like if you think about, if we wanted to find out what percentage of people in our country vote Republican or Democrat, there's literally no way that anybody would want to undertake such a heavy-duty study because it would be so costly, so time-consuming, arguably impossible to get everybody who would ever vote to get on to the voting in this, to participate in a particular survey. So the goal is to get a group of people who represent the larger population in some capacity, and sample them and then draw conclusions. Now, to give you a few other examples, the What Coaches Can Do for You article, that was an example of descriptive statistics. So if you want to take a look at that, if you remember, I gave that to you during class, and it was just a set of questions of two people about, for example, why they were engaged to work with clients, and how they contacted people, if I remember correctly. And what was reported was essentially a percentage of people who voted a particular way or responded a particular way. So as one example, it might be that 50% of them were contacted by the client, 40% were referred to them by HR, but those are probably not accurate statistics. But the key is that all that article does, and it was the Harvard Business Review article that I gave you on what can coaching do for you. It's just a report on that particular sample and what percentage of them responded a particular way. Now, by comparison, the Building Successful Coaching Relationships article involves inferential statistics, because what they did, if you remember, the main things that they were looking at there is how people were matched, whether in complementary ways, what kind of impact that had on the quality of the relationship, and subsequently the outcomes associated with that. And so what they did is they collected information from, say, a number of different people. Let's say it was something like 60 to 70 pairs of people, coaches and their coachees. And from those 70-ish pairs, they derived conclusions about all coaches to say, if you're matched better, you're likely to have a better relationship and subsequently have experienced better outcomes. So there's some difference there. So in your homework, which I'll get to later, the Dawson-Long article has some inferential statistics, but not in Table 1, which only showed mean and standard deviation, which are descriptive. Okay, now the mean is the biggie in descriptive statistics. And essentially it means the average, which we talked about in our class. It is a basic statistic. Everybody can get this. And the mean measures what's called the central tendency of the data that you've collected. The other two central tendency measures are the median and the mean. And let me show you. Let's see. Bear with me, I had this nicely organized. Okay, this is what I wanted to show you. This is one example of the average, the mean. So if you basically added those all up and divided by the number of data points that you have, you get the mean. And then what I did here to the right in column C is I copied and pasted the data and put it in ascending order, starting with the lowest number 50 going all the way up to 70. Now the mode, as you should know from your earlier class or your earlier reading of the chapters and the homework, is the mode is the number that appears most frequently. That can be a value to you in understanding your data. In addition, the median is the number that is in the very middle of the data. So there are just as many data points below the median as there are above the median. And in this case, notice that they're all the same. The average here is 60. The most frequently, actually, the numbers all appear the same number of times. So 50 appears 4 times, 55 appears 4 times. So you could state that the mode is 60 in that particular case, as it is one of the numbers that appears most frequently, and the median is the number in the middle of the data. And so all of those give you some understanding of your data, and it's what's called central tendency. So we'll get to more of that a little bit later. Okay, now what I just showed you is, let me see here. What I just showed you is this particular data. I call it normal data. And that is when the mean, median, and mode are all essentially the same. And so even if you look at this intuitively, you should see that this is normal data, meaning that they're all the same and they're subject to what's called a normal distribution, which we'll get to in just a few minutes. There's an assumption made in a lot of statistical procedures that the data is, quote, normal. That is, it's bell-shaped and it's symmetrical, which I'll talk about a little bit later. So if you just look in this first column to the left, you can see the average is 60. Then if you look to the second and third columns, since everything is 50 and everything is 70, if you add them up and average them, again, you get 60. And if you look to the far right columns, the average of 55 and 65 is again 60. So essentially, the data is all three, the median, the mode, and the mean, are all going to be the same in this case. Okay. Now, one thing that I want to get to is this notion of the mean in the Das and Long article. So, which is one of the homework questions for you. The attribute that's considered the most important to determining interesting research, according to Das and Long, was investigates totally new problem or questions. And what I did here is just picked out a number of different potential data points that could have averaged out to 3.24, which was the mean in that particular case. So what I want you to do is just get used to how the data actually looks. And you should have gotten that out of doing the sample questions in the chapters in the book, the statistics book. But to be sure, this is, whatever this is, 20 data points. So this would be, as an example, the response from person one. So when person one filled out the survey in taking the Das and Long survey, he or she wrote, okay, I think that investigates totally new questions is a 3. It's almost, 4 was the highest, extremely important. But in this case, this person wrote, it's actually important to investigate totally new questions if you're going to be interesting. Person 2 stated the same thing, 3, 4, 5, 6, 7, 8, 9, 10. But then as we get through 16 to 20, these people actually thought that investigating totally new questions was extremely important if you were going to have interesting research. So again, I didn't truly average these numbers, but intuitively you could see if you averaged all of these numbers, you're probably going to get something close to 3.24. And that was the essence of the mean in that article for that particular attribute. If we go back to it, we can see, again, if you look at this, pretty much everything is a 2 or a 1 except investigates totally new questions or novel topics. So because it has the highest mean, and that is the one closest to 4, which was extremely important, we know that that is the most important attribute in terms of making research interesting. I'm going to move on to my next video here to make sure it can be posted.